Hello, this is Jacobian part 2, just like the last Jacobian video. In this video I will be doing many problems. Okay, that's last time we have done 2 into 2 and 3 into 3 videos. So this time I will be doing n into n models as well. So how to start? Okay, for example, in a question they have given you a variable structure. That is, if y1 equal to 1 minus x1, y2 equal to 1 minus x2 into x1, okay, and y3 equal to x1 x2 into 1 minus x3. So you're getting the pattern. So y1 will obviously x1 x2 dot 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 xn minus 1 minus xn. So this is given. So all you have to find is the value of del of y1 y2 dot 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 yn divided by del of x1 x2 dot 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 xn. This we need to find out. Now I'm going to solve this question. Well, I would recommend you to just don't see it right now. You just take your time, try to solve it, okay, and then get back to this. This will be a relatively better exercise for you. Okay, so in this particular format we need to actually find out del y del x1 del y2 del x2 dot 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 del yn del xn. This you need to remember for nth order Jacobian structure. This time we are not going to form that n into n order determinant and then do it. We just take this part. So y1 this x1 y2 with x2 in that correspondence. So in the correspondence proceeding we will go. Okay, so the first one is minus 1, second one is minus x1, second one is third one is minus x1 and x2. In that way the last one is minus x1 x2 dot 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 xn minus 1. That's it. So simply we can take minus 1 to the power n common, and this is x1 to the power n minus 1, x2 to the power n minus 2 dot 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 xn minus 1 to the power 1. So this is the formation. So the trick is for n into n order Jacobian, we can directly write that del of y1 y2 in a small order. I'm just showing you. So this is this del y1 del x1 into del y2 del x2 and in an extensive format. Okay, we change the color with, okay, let's make the green. Okay, so now we are going to solve a similar question, but this time I will only change the format a little bit. So what happens if it's a trigonometric function? Trigonometric. So x equal to r sine theta cos phi, y equal to r sine theta sine phi, and z equal to r cos theta. So these are the three things, and obviously you can guess what they can ask you to find out. Del of x y z by del of r theta phi. What is this value? So there's no change in the process. We'll just do it del x del r. So here the process is telling we need del x del r, we need del x del theta. Del x del r will be directly sine theta cos phi. Del x del theta will be r cos theta and cos phi. I would recommend you to see my partial derivative videos if you are having any hiccups with this kind of structure. So, and finally in that way if you proceed, finally the determinant I'm rewriting will look like this: del x del r, del x del theta, del x del phi, and and then same thing with this thing y, and lastly same thing will also be coming with this structure. Oops, sorry. So, and this is del z del phi. Okay, so now we are just putting the value. I hope you have solved it yourself, so I'm just giving it. And remember that in examination also this should take almost around of 3.5 minutes of time, not more than that. Okay, so this one is very important, how you manage your time for this kind of sum. And this is sine theta, sine phi, and this is cos theta. R sine theta, this is 0, R cos theta, sine phi, R sine theta, cos phi. That's it. So here if we just put it r square sine theta, so this is sine theta cos phi, cos theta cos phi minus sine phi as well. And after that sine theta, sine phi, you have to take it common. Okay, this is cos theta. This is cos theta sine phi minus sine theta cos phi, and this one will be 0. Now, this time we don't have a shortcut over here for this particular question, so you need to just split it now. Splitting the entire determinant. If you just split it, you will finally get a value like this: r square sine theta, sine square theta plus cos square theta cos square phi plus sine square theta plus cos square theta sine square phi. So this is 1, this is 1, but ultimately this is r square sine theta. So in this way we can find the value of Jacobians with respect to trigonometric formats and in format. So now I have done with the first two videos of Jacobian. There will be another property based video that will be done in my video number 3. I'm just giving you a simple structure of the property of Jacobi. It's a very important property. Use a different color for this. Okay, so that is, if u, v are the functions of r and s, u is a function of rs, v is a function of rs. Okay, if it is like this, and r and is a function of x comma y, and s is also a function of this. So the function of a function, function of a function of a function. If these three things are given, then del of u comma v, del of x comma y equal to del of u comma v, del of r comma s, and del into del of r comma s, del of x comma y. So ultimately you are finding uv with respect to xy with a cross of rs. So this is a crossbreed structure. So you need to remember this thing, and it will be easier for you. Okay, let me change the style for this. Okay, this one is very important, uvxy, and see this cross is the extra one which I have written, that is the r and s. So r and s were at the beginning, that will become here the middlemost portion. Okay, this can be proved, and this kind of sums we will be doing as well. Let me just do one question, although I said I won't do, but I'm doing this. U equal to x square minus y square and v equal to 2xy. These are the two things, and given that r equal to x equal to r cos theta, so now it's more interesting. So trigonometry is also there, r equal y equal to r sin theta, and all you have to find is del uv. You can guess it. Yes, it is r and theta. Okay, so how to find it? Very easy. So first we need to find out del uv del xy. Okay, that we need to find out first. So that we know already. So this will be 2x minus 2y, 2y, 2x, and this is 4 into x square plus y square, and x square plus y square will be coming in the beginning. So you can see that if we just add it, x and y each squared, so it will give you r square. So this is 4r square. So this is 4r square from the first one. Similarly, del xy by del r theta, if we do it like this, so this will be cos theta, this will be sin theta, just like the very first video we have done in the basic Jacobians, and r cos theta. So this is r square sin square theta plus r square cos r sin square theta plus r cos square theta, so r into 1. This one is simply r itself. And now all you have to do is just multiply them. So this is 4r square into r, so the answer is 4r cube. So this is so easy to do the triple order structures of the Jacobian. Okay, there will be another property I will be discussing in my next video. Thank you.